Fire is one of the most useful tools ever discovered. It can transform wood into ash, light up the night, and keep us warm. For two brothers living in France in the 18th century, fire was more. It held a promise of flight. Jacques and Joseph Montgolfier observed that the flames of a fire rise upward, occasionally taking with them cinders or ash. It seemed that the cinders were carried on a wind of rising gas, and from this they deduced that the air heated by the flames was buoyant. The heat of the fire somehow caused the air to go up. If this buoyant air could be confined in a balloon, then maybe, like the cinders, the balloon would rise, and the Montgolfiers would realize the age-old dream of flight. On June 5, 1783, Jacques and Joseph Montgolfier heated the air in a large linen bag, and when they released it, the bag climbed to an astonishing height of 1,500 feet.
Jacques-Alexandre Charles, a French scientist, became fascinated with balloons and the gases that filled them. In 1787, Charles performed an experiment very similar to the one with the capillary tube and thermometer. He discovered that for an increase in temperature, gas volume increases proportionally. This is known as Charles' law.
This balloon was placed in the freezer. When it warms to room temperature, what do you think will happen? As the balloon warms, the gas expands and the balloon becomes taut.
This balloon will be placed in very cold liquid nitrogen. How will the size of the balloon be affected?
The direct relationship can be shown in a graph or a table.
In the following examples, before the temperature of the gas is changed, V1 represents the first or initial volume of a gas, and T1 represents the first or initial temperature. After the temperature of the gas is changed, V2 represents the second or final volume, and T2 represents the second or final temperature. The relationship between volume and absolute temperature is known as Charles' law. It can be represented by the equation V1 divided by T1 is equal to V2 divided by T2.